Hi friends, good morning one and all. This is again your Virat Kumar, lecturer in electrical and electronics engineering. Today we will see about the engineering curves part 2 regarding spiral and helix. So this is related to spiral and this is related to helix. So in the previous class we have seen about the cycloid. There are methods of phi like general cycloid, trochoid, of superior and inferior, epicycloid and hypocycloid. So in this today's session we will see about how to draw a spiral and helix and some methods of drawing tangents and normals to these above curves. So coming to the spiral, there are two methods. One is spiral of one convolution and the second one is spiral of two convolutions. And coming to helix, again there are two methods. The helix is on cylinder and the other is on a cone. So in this session we will see about how to draw a spiral and helix, and also we will see some methods of drawing tangents and normals to these above curves for involute, cycloid, spiral and helix. See, what is spiral and helix are called spiral. It is a curve generated by a point which revolves around a fixed point and at the same moves towards it. So what's a spiral? It is a curve generated by a point which revolves around a fixed point and at the same moves towards it. And regarding helix, it is a curve generated by a point which moves around the surface of a right circular cylinder or cone and at the same time advances in axial direction at a speed bearing a constant ratio to the speed of rotation. So for problems, refer topics of development of surfaces. Okay, so helix is a curve generated by a point which moves around the surface of a right circular cylinder or cone and at the same time advances in axial direction at the speed bearing a constant ratio to the speed of rotation. So spiral. So similarly, as usually, we just don't step into the theoretical concept, we'll directly move on to the problem, solved problems. It's problem number 27. Draw a spiral of one convolution, take distance PO of 40 mm. So it's a draw a spiral of one convolution and take a distance PO of 40 mm. So the important approach for construction is find total angular and total linear displacement and divide both into same number of equal parts. What is saying? The important approach for construction is find total angular and total linear displacement and divide both into same number of equal parts. Now there are some simple steps to solve this above problem. There are 4 steps to solve it. First one is, with PO radius, draw a circle and divide it into 8 equal parts and name them 1, 2, 3, 4 and etc. up to 8. What is the first step? With PO radius, draw a circle and divide it into 8 parts, name them 1 to 3 and so on to 8. Similarly, divide line PO also in 8 equal parts and name them 1 to 3 and so on to 8. Now take O to 1 distance from OP line and draw an arc up to O1 radius vector and name the points P1. Similarly, mark all the points as P2, P3, P4 and so on up to P8 and join those in a smooth curve in a spiral of one convolution. So, by that hence you will be obtaining a spiral. Now, we will see the construction part. See, firstly take a distance or a die of 40 mm and draw a circle. See, with PO radius draw a circle and divide into 8 equal parts and name them 1, 2, 3, 4 and so on. The 8th point is P itself, the center is O. Divide OP again into 8 equal parts and name them 1, 2, 3, 4 so on to 8. 8 is O. Now take O to 1, this is O, the center one is O, this center one is O, okay. Okay, from O to 1 as radius or the vector, draw the arc on the one line. Similarly, from O to 2 on the second line, O to 3 to third, 4 to 4, O to 5 to 5, O to 6 to 7th line, and O to 8 is within there itself. Now mark all the points, all the intersections. Now join all the points smoothly in order to obtain a required spiral. Before that, name all these points as P1, P2, P3 and so on up to P8. Now join all the points smoothly in order to obtain your required spiral. So, this is the required spiral of one convolution. Okay, we will see it again. Draw the circle with a given radius and divide into 8 number of equal parts and name them in the anti-clockwise direction from 1 to so on to 8. And then from the center O to P, divide again into 8 equal parts and name them from 1 to 8 towards left, from right to left, from right to left. Now O to 1 as radius, O to 1, draw an cutting sections to 1, O to 2 to 2 and so on to 8, O to 6 to 6, O to 7 to 7. Now mark all the points at the intersections. Then name them as P1, P2, P3 and so on up to P8. Now join all these points smoothly in order to obtain your required spiral. So just take a couple of minutes to solve these and make in your observation notes so that you will be very clear to it. Okay, this is about your spiral of one convolution. Next we will move on to the next one. So spiral of two convolutions. So previously we have seen spiral of one convolution and now we will see spiral of two convolutions. See the problem again. Point P is 80 mm from point O. It starts moving towards O and reaches it in 2 revolutions around it, and draw locus of point P to draw a spiral of two convolutions. What is saying? He is saying that there is a point P is 80 mm from point O. That means O to P the distance is 80 mm. It's the radius. It starts moving towards O and reaches it in 2 revolutions around it, draw locus of the point. So the important approach for construction is to find total angular and total linear displacement and divide both into same number of equal parts as usual in the spiral of one convolution. Now some solving steps. Total angular displacement here is 2. Total angular displacement here is 2 revolutions, and total linear displacement here is distance PO. So just divide both in same parts, therefore circle in 8 parts and also line in 8 parts. That means total angular displacement will be in 16 parts. So divide PO also in 16 parts. So the rest steps are similar to the previous problem. Okay, this is an OP and there is a circle into 8 equal parts, naming them. There are 2 circles. So since 1, 2, 3, 4, 5, 6, 7, 8, again from 9, 10, 11, 12 to 16. So OP line is divided into 16 equal parts, naming from right to left. So similarly 1 to 1 is already there, 2 to it's P, that is 1, 1 to 1, 2 to 2, taking O to 1, which are the similar steps as the previous problem. O to 1, cut the one line, O to 2, cut the second line, O to 3 as the radius, cut the third line, O to 4 and so on up to O to 16. So it's 1, 2, 3, 4, 5, 6 to 7, to 7, 8, 10, 11, 12, 13, 13, that is 14, 14, 15 done, 15. Now points, it's last 1, 2, 3, 4, 5, 6, 7, 8th one is over there, since 8th line is that one only 8, it's 9, 10, 11, 12, 13, 14, 15 and 16. Now join all these points smoothly in order to obtain your spiral of 2 convolutions. So this is your spiral of 2 convolutions. So these are the points of P15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and P. So this is the spiral of 2 convolutions. So in previous problem we have seen the spiral of only 1 convolution, and this is the spiral of 2 convolutions. We will see it again. Okay, draw an OP line with the 16 points in it. O and center, draw a circle, extend it as a diagonal, divide the circle into 8 and 8 equal parts, total 16, name them. There are double circles in it, since it is a 2 revolutions. Now this is an OP line, and mark them 1 to 16 from right to left. Now O2, one has radius, draw an arc up to the line 1. Similarly O2, 2 to 2, 3 to 3, 4 to 4, 5 to 5, 6 to 6, 7 to 7, 8 occurs only there itself. This is again 14, 9, 10, 11, 12, 15, 12. This is 13, 14, 'Now join all the points. Now firstly mark the points 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Now join all these points smoothly in order to obtain your required spiral of 2 convolutions, and also name the points 15, 14, 12 and so on to 1. So take couple of minutes and complete the diagram. Okay, now we will move on to the next topic, which is nothing but helix. Helix upon a cylinder and a cone. Firstly, we will see helix upon a cylinder. There is a problem over here. Draw a helix of one convolution up to a upon a cylinder. Draw a helix of one convolution upon a cylinder. Given 80 mm pitch and 50 mm diameter of a cylinder. The axial advance during one complete revolution is called the pitch of the helix. What is saying? Draw a helix of one convolution upon a cylinder with given 80 mm pitch and 50 mm diameter of a cylinder. The axial advance during one complete revolution is called the pitch of the helix. Now there are some simple solutions to solve it. Firstly, draw projections of a cylinder. Divide circle and axis in same number of equal parts, say 8. Name those as shown from 1 to 8. Make initial positions of point P and mark various positions of P as shown in animation, and join all points by smooth possible curves and make upper half dotted as it is going behind the solid and hence will not be seen from the front side. Okay, these are some solutions. We will see the projections. So, a cylinder, top view looks like a circle which is having a 50 mm dia, and front view looks like a rectangle with its projections of height 80 mm pitch. Now divide the circle into 8 equal parts and name them as 1, 2, 3, 4, 7 to P, and take the projections in the same way towards the front view. Now mark the same points to the front view. Divide that again into 8 equal parts. Now it's 1 to 1, it's 2 to 2, 3 to 3, 4 to 4, 5 to 5, and 6 to 6, 7 to 7, and 8 to 8. So name them as P1, P2, 3, 4, 5, 6, 7, and 8. Now join all these points smoothly in order to obtain your required helix. Now the lower half is in the dark line and the upper half is in the dotted line. Since the cylinder looks in this way, so the section will be after this, and the backside one is invisible, so that should be in dotted line. That should be in dotted line. So that's the reason why why the upper half helix is in dotted but not the lower one. Okay, we'll see it again. Firstly, draw a cylinder with required or given diameter of 50 mm. Draw the projections of it and divide the circle into 8 equal parts and name them in the anti-clockwise direction. Mark 8th point as P and take the projections towards front view and also divide that into 8 equal parts and name them from 1 to 8 and make the points from 1 to 1, 2 to 2 and so on up to 8 to 8. And so on up to 8 to 8. Name them P1, P2, P3, P4, 5 and so on up to P8. Join all these points smoothly in order to obtain your required helix. The lower part is in the front and the upper part of the helix is behind the cylinder, so it is not visible and so it is drawn in dotted line, and the lower part of the helix is in the front which is visible to you, so that is in the dark line. So take a couple of minutes and make the question and answer. Neatly. Okay, now we'll move on to the next topic, helix upon a cone. See the second helix upon a cone. There is a problem in it. Draw a helix of one convolution upon a cone with diameter of base 70 mm and axis 90 mm, nothing but 90 mm pitch. The axial advance during one complete revolution is called the pitch of the helix. From the previous one to this, the procedure is just similar, but whereas it is a cylinder and this is a cone. See the solution steps. Draw projections of a cone. Divide the circle and axis in same number of equal parts, say 8, and note those as shown and name them nothing but as shown from 1 to 8 in the order of anti-clockwise. Mark initial positions of point P. Mark various positions of P as shown in animation. Join all the points by smooth possible curve and make upper half dotted and as it is going behind the solid and hence will not be seen or visible from front side, and hence make lower half as your straight and dark line since it is visible to you. Okay, so draw an helix of one convolution upon a cone, diameter of base 70 mm. So draw a circle of 70 mm dia and take the projections and draw a cone. The front view looks in the triangle order, which has the axis and height, nothing but pitch as 90 mm. So dividing the circle into 8 equal parts, name them 1, 2, 3, 4 and so on up to 8. Mark 8th point as P in the anti-clockwise order. You can see in the animation. Now take the projections and divide the line of your cone, front view of your cone of any one side into 8 equal parts and name them from 1 to 8 as shown in your animation. Now mark all the points from 1 to 1, 2 to 2 and so on up to 8 to 8. It's 8 to 8. Now 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5, 6 to 6, 7 to 7 and 8 to 8. Now join all the points. Before that, name them P1, P2, P3, P4, P5, P6, P7 and P8. So this will be your helix upon a cone. So the lower half is in the dark straight line and the upper half is in the half dotted. Upper half looks like a dotted as it is going behind the solid and hence will not be visible from the front side. Okay, we'll see it again. Draw a circle, divide into 8 equal parts, and draw the projections of the circle. And the cone front view looks like a triangle and the top view looks like a base of circle. Mark them from 1 to 8, 8th point as P. Take the projections of all the lines from 1, 2, 3 and so on to 8. Now divide one of the slant height of the triangle into 8 equal parts and name them from 1 to 8. Now mark the points from 1 to 1, 2 to 2, 3 to 3 and so on up to 8 to 8, nothing but P to P as shown in the animation. Now join all the, now before that name them. After naming, join all the points smoothly. So this is your required helix upon a cone. Just take a minute and draw the diagram in your observation notes. So these are about spiral and helix. We have seen two methods in spiral and again two methods in helix. Now we'll see about the tangents, how to draw the tangents to the above curves for all the involute, cycloid, spiral and helix. These are the leftover projections. No. Actually, this spiral, it looks from the top view too. It looks in this order. So it looks in this way. So this is obtained see, taking the projections from the points P1, P2 and so on up to P8, P1 to 1, P2 to second line at the center, P3 to the second one only, P3, P4, P5, P6, P6 again M6, so 6 to this and an arc, P7, P8 is at the center. So this will be 1, 2, 3, 4, 5, that's a 6, 7, that is 8. Now join all the points before that, making P1, P2, P6, P7 and P8. Join the points. So this is your required, this is the spiral and that is your helix. This will be your spiral and this is your helix. Okay, now we'll move on to the tangents. So involute method of drawing tangent and normal. So step, draw involute as usual, mark point Q on it as directed. See, this is already a well known involute to you. Mark point Q on it, mark anywhere on the curve a point named as Q. Now join Q to the center of the circle C. So Q to C. C join Q to the center of the circle C. Considering CQ diameter, draw a semicircle as shown. So CQ as said, draw a semicircle. Now mark point of intersection of this semicircle and pole circle and join it to Q. So this will be normal to involute, and draw a line at right angle to this line or a bisecting line or a 90 degrees line in order to obtain your required tangent. So this is your tangent, blue colored line is your tangent and the pink colored line is your normal. Is it clear? Or shall we see it again? Mark a point anywhere on the curve, mark it as Q and join Q to C. So Q to C as dia, draw a semicircle which is cutting the circle somewhere and join that point cutting circle to Q. This will be your normal, and draw a 90 degrees line or a bisecting line passing through the curve is your tangent. Now a tangent and normal to a cycloid. So cycloid method of drawing tangent and normal. So this will be all this, so the same thing. Mark a point anywhere on the curve and name it as Q and draw a line. See, draw cycloid as usual, mark point Q on it as directed with CP distance. From Q, cut the point and locus of C and join it to Q. So from this point drop a perpendicular on ground line. So this is CP, a perpendicular line on ground line and name it N. Join N with Q, which is your normal to cycloid, and draw a perpendicular line or a right angle line to this normal passing through the curve will be your tangent. So blue colored one is your tangent and the pink colored one is your normal. Spiral method of drawing tangent and normal. This is something different. So constant of the curve is equal to difference in length of any radius vectors divided by angle between the corresponding radius vector in radians. So that gives you OP minus OP2 by pi by 2 is equal to OP minus OP2 by 1.57, which is nothing but 3.185 mm. So same, draw spiral as usual. For one convolute or two convolute, draw a small circle of radius at the constant of curve calculated above. So locate point P, point Q as directed from the problem and through it point anywhere on the curve and name it as Q. Locate point Q as directed in problem and through it draw a tangent. That's your 3.18 mm circle. This small circle, this is a normal to the sphere, and draw the line at right angle will be your tangent. So the smaller circle constant of the curve is 3.18 mm. It's a curve, small circle. Draw a small circle of radius. See here the small circle. Draw a small circle of radius equal to the constant of the curve calculated above. So this is your radius. So this is about the tangent and normals to the above curves. So tangent and normal is not to be done to your helix, it's only to involute cycloid and spiral. So helix is some different thing. Okay, this is about your engineering curves part 2, like involute, cycloid, spiral and helix. We have seen all the things in tangents and normals. So that's up for today's session. I hope you have gone through all these things, you have understood very well. So signing off, thank you one and all.